The silence of space is an illusion. A cosmic conversation could be happening all around us, on channels we have not yet learned to tune into. This is the idea of the Intergalactic Internet, a hidden network of alien communication. By the end of this video, you will know 30 specific ways this dialogue might be occurring right now. Methods that stretch from the fabric of spacetime to the particles in your body. We will explore how messages might be hidden in the afterglow of the Big Bang and why a dying star's final blast could be a deliberate signal. What does it mean for humanity if we are not alone, but simply unaware? Two particles born from the same event can become permanently linked. This is the strange reality of quantum entanglement, a connection so profound that a change to one particle is instantly mirrored in its partner, even if they are separated by the entire galaxy. Albert Einstein himself found this idea unsettling, calling it spooky action at a distance. Yet this spookiness is not just theoretical, it is a proven cornerstone of modern physics. For an advanced alien civilization, this phenomenon could be the ultimate communication tool. Imagine building a network of entangled particles, spreading them across star systems to create a web of instant contact. Information encoded in the quantum states of these particles would travel faster than light itself. A conversation with a being in a distant nebula would have no lag, no delay. A message sent is a message received in the very same instant, rendering the slow speed of light a trivial obstacle of a bygone era. How could we ever hope to notice such a system? We might detect unexplained quantum decoherence in the void of space, or find subtle, artificial patterns etched into the cosmic microwave background, the ancient light from the Big Bang. This quantum network suggests a universe intricately woven together, where the very fabric of reality hums with conversation. And this fabric might hold another secret, one where spacetime itself is the medium. Those quantum whispers are not the only hidden channel. The fabric of spacetime itself may be humming with deliberate signals. Gravitational waves are the ripples that travel through this cosmic fabric, generated by the most violent events in the universe, like the collision of two black holes. We know they exist, we have felt their tremor pass through the Earth. Now, picture a civilization so advanced it does not just listen for these ripples, it creates them. Think of our cosmos as a vast, tranquil pond. Natural events are like stones dropped in, creating chaotic splashes. But an advanced intelligence could learn to tap the surface with perfect, rhythmic precision. They could modulate these gravitational waves, encoding complex information within the subtle variations of their amplitude and frequency. This would be a communication system of unparalleled sophistication. Gravitational waves travel at the speed of light and pass through nearly everything in their path, from interstellar dust clouds to entire planets, without being distorted or absorbed. A message sent this way would be crystal clear across unimaginable distances, a robust signal almost impossible to intercept or jam. How might they do it? A species could engineer colossal structures, perhaps by orchestrating the precise orbits of neutron stars or manipulating masses we cannot yet conceive of, to generate these controlled tremors in spacetime. They would be turning the universe itself into a resonant medium, a cosmic telegraph. For us, detecting this artificial chatter would mean searching for patterns that defy all natural explanation. Our next generation of gravitational wave observatories, with their incredible sensitivity, might one day pick up a sequence of ripples that is too orderly, too perfectly patterned to be anything but a product of intelligence. It would be a message written not in light or sound, but in the subtle vibrations of reality, And if a civilization can manipulate the force that bends space, what about the forces that hold matter itself together? The same forces that sculpt the cosmos could be harnessed to send a whisper. While we feel the tremors of colliding black holes, a far more subtle vibration might carry a deliberate message. Neutrinos are ghostly subatomic particles that flood the universe, streaming from the sun and distant supernova. Their defining trait is their profound indifference to almost everything. Trillions of these particles pass straight through your body, and indeed through the entire Earth, every single second without leaving a trace. For an advanced civilization, this very property makes neutrinos the perfect interstellar messengers. Imagine an alien race generating an intensely focused beam of these particles, encoding vast libraries of information within their subtle properties, and aiming this beam with pinpoint accuracy at a target star system. Unlike radio waves, which can be scattered and absorbed by interstellar gas and dust, a neutrino beam would travel in an almost perfectly straight line. It would pierce directly through planets, stars, and nebulas as if they were not even there, arriving at its destination with the message perfectly intact. The challenge, of course, is not just sending the signal, but receiving it. To capture these cosmic couriers, a civilization would need massive, exquisitely sensitive detectors, perhaps buried deep underground to shield them from other cosmic noise, or positioned in the pristine quiet of deep space. The incredible part is that this is not pure science fiction. Scientists on Earth are already experimenting with neutrino communication, proving that we can use these elusive particles to send secure messages through the planet itself. To find an alien signal, we would need to scan the constant, natural rain of neutrinos for something that stands out, for unnatural patterns that defy explanation. We would be searching for repetitive pulses, complex modulations, or a signal that is just too orderly to come from a supernova or a star. It would be a sequence hidden in plain sight, a secret handshake conducted with particles that barely acknowledge our existence. This method turns the universe's most elusive ghosts into its most reliable couriers. And if a message can be sent using particles that ignore matter, what about a message sent using the matter that is all around us? Our universe is built on a hidden scaffold, a framework we cannot see. This is the realm of dark matter, the mysterious substance that binds galaxies together with its gravitational pull. It is everywhere, yet it reveals nothing of itself, refusing to interact with the light we use to explore the cosmos. But what if that invisibility is its greatest asset for communication? An intelligence that has mastered the universe's dark side could be using this very scaffold as a galactic messaging system. They would not need to create signals we can see. Instead, they could learn to manipulate the density of dark matter itself, sending waves of compression and rarefaction through its invisible ocean. Information could be encoded in the precise rhythm of these density fluctuations, a subtle drumbeat echoing through the cosmic web that connects all galaxies. This would create a background communication grid so fundamental and widespread that it would be the universe's ultimate infrastructure, a hidden internet operating entirely outside our normal channels of perception. Detecting such a system is a monumental challenge. We have not yet directly observed a single dark matter particle, let alone mapped its subtle ebbs and flows with the precision needed to spot an artificial pattern. Yet future observatories designed to chart the gravitational influence of dark matter with unprecedented detail might one day notice something strange. They could detect ripples that are too orderly or density variations that form a complex, repeating sequence defying any natural explanation. Finding such a structure would be like listening to static and suddenly hearing a perfect mathematical melody emerge. It would mean that the vast, dark foundation of our cosmos is not silent, but is in fact buzzing with data exchanges we are only now learning to conceive of. This form of communication is the definition of stealth, a conversation happening in the shadows of reality itself. And if messages can be hidden in the universe's invisible mass, they could also be concealed within the very energy that fills empty space. The oldest light in the universe might already contain a message. This is the cosmic microwave background, the faint, cold whisper of the Big Bang that permeates all of space. For a civilization that has mastered cosmology, this primordial radiation could serve as the ultimate billboard. They would not need to send a signal that fades over time. Instead, they could permanently alter the canvas of the sky itself, engineering subtle changes in the temperature or the polarization of this ancient light to encode information. The resulting pattern would be a broadcast on a truly cosmic scale, visible from any point in the galaxy and enduring for billions of years. The engineering feat required is almost beyond comprehension. It might involve manipulating fundamental energy fields in the early universe or constructing vast, opaque screens, Dyson spheres on an unimaginable scale, placed strategically to cast deliberate shadows or create artificial hotspots in the background radiation. For us, the search is already underway. Our detailed maps of the cosmic microwave background, like those from the Planck satellite, show a universe of random quantum fluctuations. But what if a future, more sensitive survey discovers something that breaks this pattern? An anomaly with perfect geometric symmetry, a sequence of hot and cold spots that forms a repeating mathematical sequence, or a region of the sky that is just too orderly to be natural. Finding such a signature would be like discovering that the foundation of reality itself has been signed. It would be a message meant not for a single generation, but for all intelligent life that ever evolves to look up at the cosmic dawn. This is communication as legacy, a permanent postscript to creation. Yet, if some civilizations plan for the long term, others might use the universe's most violent explosions to send a more urgent, fleeting signal. A dying star's final scream could be a deliberate shout into the void. Gamma-ray bursts are the universe's most powerful explosions, events so catastrophic they outshine entire galaxies for a few fleeting seconds. In that brief, unimaginable flash, more energy is released than our sun will produce over its entire 10 billion-year life. For an advanced civilization, this raw power is not just a spectacle, it is a tool. Imagine a species that has learned to harness these cosmic detonations. They could engineer the collapse of a star or the collision of dense stellar remnants, triggering a gamma-ray burst on demand. But they would not just create a random explosion, they would carefully modulate it, controlling its precise timing, its duration, and the specific energies of the gamma rays it emits. In doing so, they could encode a message within the burst's very profile, turning a cataclysm into a form of interstellar Morse code. The signal would be brief, yes, but so intensely bright that it could be seen from the other side of the observable universe. It would be the ultimate way to get someone's attention, a cosmic flare gun announcing, "We are here." For us, the challenge is immense. Our telescopes detect gamma-ray bursts regularly, and we classify them as natural events, the deaths of massive stars or the mergers of neutron stars. To find an artificial one, we would have to look for the subtle signatures of design. Does a burst have a profile that is too clean, too symmetrical? Does it repeat from the same location in a pattern that defies natural probability? Does its energy spectrum contain odd, unexplained features that no astrophysical model can account for? Some theoretical concepts suggest a network of colossal energy beams, focused with unimaginable precision, could be used to generate these signals artificially. Finding one would mean sifting through the universe's most violent moments and discovering a pattern, a whisper of intent within the roar. This method turns the cosmos's greatest tantrums into a precise, if fleeting, language. But not all messages need to be so urgent and brilliant. Some conversations are built to last for eons, inscribed not in light but in stone. The galaxy's most reliable timekeepers might already be broadcasting. Pulsars are the spinning corpses of massive stars, and their rotating beams of radiation sweep across space with a regularity that rivals our most precise atomic clocks. Each pulse is a tick of a cosmic metronome, so predictable that a civilization could use an entire network of them as a galactic-scale GPS. Now, envision an intelligence that has learned to nudge these clocks. By placing a massive object like a constructed sphere or another star into a precise orbit around a pulsar, they could create a subtle, repeating delay in its pulse. This gravitational drag would be a predictable, controllable effect. Information could be encoded in these tiny, engineered timing shifts, turning a natural beacon into a signaling device. The true power lies not in one pulsar, but in a synchronized array of them. By monitoring the pulse arrival times from many of these cosmic clocks across the galaxy, a message could be spread across the entire network. A single, complex instruction or a piece of data could be broken into parts, with each pulsar contributing one element of the whole. This pulsar net would be a method of communication built for the ages. It would be incredibly slow by our standards, with messages possibly taking years or decades to fully transmit, but it would be phenomenally stable and resilient, largely immune to the interference that plagues radio signals. The fascinating part is that we are already listening, just not for this. The International Pulsar Timing Array uses these precise pulsar ticks to hunt for the faint ripples of gravitational waves. In their meticulous data, they might one day find something even more profound, a set of timing anomalies that are just too coordinated, too patterned across multiple pulsars to be a natural phenomenon. Decoding such a message would be like solving a puzzle where the pieces are scattered across the entire galaxy, requiring us to see the intricate pattern connecting them all. It is a conversation written in the subtle hesitations of dying stars, and if a civilization can manipulate the timing of natural lighthouses, what could they achieve by building artificial ones on a scale we can barely fathom? A star that flickers in an unnatural rhythm might be more than a celestial anomaly. It could be the heartbeat of a galactic communication network. The concept of a Dyson sphere, a megastructure built around an entire star to harness its energy, represents a pinnacle of engineering. But for a civilization that has achieved this, the sphere would be more than a power source. It would be a powerful beacon. Imagine vast orbiting shades like a colossal set of louvers, periodically blocking the star's light in complex coded sequences. Or perhaps they have learned stellar engineering itself, subtly influencing the star's fusion processes to make its brightness pulse with information. This modulated starlight would be visible across interstellar distances, a signal impossible to ignore. A single Dyson sphere is a powerful transmitter, but a network of them, each one a node, creates an infrastructure for an interstellar internet. These nodes could communicate with each other using tightly focused energy beams, laser light of unimaginable power, relaying data from one star system to the next. The message would travel at the speed of light, but on a pre-established and maintained network, ensuring its delivery across the vast gulfs between stars. We are already looking for the signs without even knowing what we might find. Our search for extraterrestrial intelligence often focuses on detecting the waste heat these megastructures would inevitably radiate, a telltale infrared signature of a star seemingly wrapped in a warm, technological shell. When astronomers see a star dimming in strange, non-repeating patterns that do not match any known planetary transit, or when they detect an infrared glow that defies natural explanation, they might be witnessing not a natural phenomenon, but the traffic of a cosmic network. This method suggests a civilization that does not just live on planets, but one that operates on a stellar scale, turning suns into both their power plants and their signal towers. It implies a conversation happening not in the quiet dark, but in the very light of the stars we see every night. And if a civilization can command the power of a sun, what could they do with the fundamental building blocks of reality itself? Even the darkest depths of space could be crackling with information. A black hole, the ultimate cosmic predator, might be repurposed as a galactic communications hub. Its terrifying gravitational pull, which warps space and time into a knot, could be the very tool an advanced civilization uses to send messages with perfect clarity. Think of placing a probe, a simple reflective beacon, into a precisely calculated orbit just outside the black hole's event horizon. The black hole's gravity would act as a colossal lens, bending the light or radio waves from this probe and focusing them into a narrow, intense beam aimed at a distant star system. This would be like using the most powerful telescope in the universe, but in reverse as a transmitter. The civilization would not just be aiming a signal, they would be orchestrating a celestial dance. By subtly adjusting the probe's orbit, changing its speed or path, they could encode vast amounts of data in the timing of the pulses we receive. A slight acceleration could mean a 1, a deceleration a 0, creating a binary code written in the motion of a star. This is orbital resonance turned into a language. The black hole's spin adds another layer. A rotating black hole drags the very fabric of spacetime around with it, an effect called frame dragging. This rotation can create a phenomenon known as superradiance, where certain waves, like light or gravitational ripples, can steal energy from the black hole itself as they scatter off its gravitational field. An intelligent species could learn to trigger this, sending a weak initial signal that gets amplified exponentially into a roar as it interacts with the black hole's spin. The result is a signal of unimaginable power, broadcast across the galaxy without the sender needing to expend colossal energy. How would we ever detect such a sophisticated system? Our observatories would need to look for the unnatural rhythms in the chaos. We might detect a steady, repeating pulse of light from the vicinity of a black hole candidate, a pulse that does not match any known astrophysical process like a feeding disk. Or our gravitational wave detectors might pick up a coherent, patterned signal emanating from a place of immense gravity, a sequence of ripples that is too orderly, too information-rich, to be the result of two random objects colliding. Finding this would mean that the universe's most destructive forces are not just in points, but instruments. It transforms a place of no return into a central switching station for an intergalactic network, proving that true mastery lies not in fighting the laws of physics, but in bending them to your will. The vacuum of space is not an empty stage, but a seething, vibrant actor. At the smallest scales, what we perceive as nothing is actually a turbulent sea of quantum potential. Virtual particles flicker into and out of existence in a continuous, chaotic dance, borrowing energy from the void for fleeting moments before vanishing again. This is the quantum vacuum, and for a civilization that has mastered the fabric of reality, this seething foam could be the ultimate communication channel. They would not be sending signals through space, but manipulating the stage upon which space itself is built. By inducing controlled excitations in this quantum field, they could encode data in the subtle patterns of these virtual particles or in the tiny ripples of energy density they create. Imagine it as sending a message not by writing on paper, but by subtly rearranging the very fibers that constitute the paper. This form of communication would be fundamentally stealthy, operating at the unimaginably tiny Planck scale, far below the sensitivity of any detector we currently possess. The signals would be immune to all conventional interference, as they would not be traveling through the universe so much as they would be manipulating the universe's underlying substrate. Some theories even suggest information could propagate through this quantum foam instantaneously, using connections that transcend our classical understanding of distance. How could we ever hope to notice such a conversation? We would need a new class of quantum gravity sensors, devices capable of measuring the most infinitesimal fluctuations in spacetime geometry itself. We would be listening for a whisper in the static of creation, searching for an artificial pattern in the chaotic hum of the vacuum. This concept stretches the limits of known physics, suggesting that the universe's most fundamental layer, the very emptiness we once thought was silent, might in fact be buzzing with the most private and profound of dialogues. It forces us to reconsider what we mean by nothing, hinting that the void is anything but empty. And if a civilization can manipulate the vacuum itself, what could they do with the most abundant raw material in the cosmos? Our own sun constantly breathes a stream of charged particles into the void. This solar wind, a plasma of electrons and protons, flows past the planets and carves a bubble in the interstellar medium that extends far beyond Pluto. Now envision a civilization that treats its star not just as a power source, but as a cosmic broadcaster. They could construct colossal magnetic field generators in close orbit, or build immense particle accelerators that tap directly into the star's corona. These megastructures would not stop the stellar wind, but they would shape it by artificially modulating the wind's intensity, its density, or even the specific mix of particles within it. They could encode a message directly into this ceaseless, flowing river of plasma. The star itself becomes the transmitter, and its stellar wind becomes the carrier wave for a signal that travels for light years. Detecting such a broadcast is a monumental task, but not an impossible one. It would require a dedicated observatory, perhaps stationed in the quiet outer reaches of a solar system, designed to analyze the incoming stellar winds from our nearest stellar neighbors. Scientists would not be listening for a sound, but instead looking for patterns in the data. They would search for strange, repeating sequences in the particle flux, or anomalous, structured variations in the embedded magnetic fields that define natural stellar activity cycles. Our own Voyager probes have already paved the way, sampling the boundaries where our sun's wind meets the galactic medium. A future interstellar mission, armed with sensitive particle detectors, might one day point its instruments at a star like Proxima Centauri and find a signal hidden in its breath, a complex modulation riding on a torrent of charged particles. This method turns a fundamental stellar process into a potential broadband channel, a conversation flowing on the cosmic currents that connect all stars. And if a message can be written in a stream of particles, what could be achieved by bending the very light those particles emit? The universe's natural telescopes offer another channel for cosmic conversation. Gravitational lensing bends the path of light around massive objects, creating a magnifying effect we already use to peer at distant galaxies. An advanced civilization would not just observe this phenomenon, they would engineer it. By placing a network of massive objects, whether artificial constructs or carefully chosen stars, into precise alignment, they could create a staged lensing array. This chain of cosmic lenses would focus a signal, be it laser light or another form of radiation, into an incredibly tight and powerful beam capable of crossing the void between stars with almost no loss of strength. It would be the ultimate solution to the inverse square law, the rule that makes ordinary signals fade to a whisper over distance. Such a system would form the backbone of a true galactic internet, a series of relay stations enabling high-bandwidth transfers of immense data sets between civilizations. Finding evidence of this would require a sharp astronomical eye. We might detect a beam of energy so perfectly collimated that it seems to defy physics, a needle-thin strand of light with no natural source, tracing its origin back to a seemingly empty point in space where a lensing array is perfectly aligned. Or our telescopes might spot an odd structure, a megastructure built not to capture a star's energy, but to perfectly sculpt its gravitational field into a more effective lens. This method reveals a profound elegance, a civilization that does not fight the warp and weft of space-time, but weaves it into the fabric of their communications network. Such mastery over light itself suggests another possibility, one that uses a far more transient and delicate canvas for its messages. An entire planet's atmosphere could be broadcasting a message we are already equipped to read. We search distant worlds for the chemical signs of life, like oxygen or methane, but a sophisticated civilization might deliberately engineer its air to send a far clearer signal. They could seed their skies with artificial, complex molecules that have no plausible natural origin. Imagine advanced industrial compounds like specific chlorofluorocarbons or entirely novel synthetic gases released into the stratosphere in a precise, rhythmic sequence. This would not be accidental pollution, but a carefully designed atmospheric code. Our most powerful telescopes, such as the James Webb Space Telescope, are already performing spectroscopy on exoplanet atmospheres, breaking their light down into chemical fingerprints. Within that data, astronomers would search for an anomaly, a pattern of gases that defies all known chemistry. It might be an impossible ratio of two compounds, or a repeating cycle of a gas appearing and disappearing that correlates with no natural seasonal change. Detecting such a structure would be monumental. It would point not merely to life, but to a civilization capable of planetary-scale geoengineering, a society that has chosen to turn its entire world into a beacon. This method creates a signal that is both persistent and widespread, enduring for decades or even centuries, a constant declaration of intelligence written in the very air of another world. And as we look for messages inscribed on planets, we must also consider the vast, empty canvas that lies between them. Some of the cosmos's most beautiful nebulae might be more than natural formations. The faint gas and dust drifting between stars, the interstellar medium, could be the canvas for a truly galactic art project. A civilization operating on an epic scale could manipulate this raw material, using focused beams of energy to ionize colossal clouds of hydrogen. This would cause the gas to glow not in the random, wispy shapes of nature, but in precise geometric forms. Imagine a perfect triangle or a complex fractal pattern etched across light years of space, glowing with the distinct red light of energized hydrogen. Alternatively, they might deploy countless microscopic probes to gather and arrange interstellar dust. These nanites could form a vast, reflective surface, a mirror the size of a solar system. When a nearby star's light strikes this artificial formation, it would create a brilliant, temporary signal, perhaps spelling out a universal constant like pi or a simple geometric proof. For us, the discovery would come from our sky surveys. An astronomer analyzing data might find a nebula with impossibly sharp angles, or a cloud of dust that reflects light in a perfect, repeating sequence of pulses, a pattern that screams of design. It would be cosmic graffiti on the grandest scale, a message written not for a single world, but for anyone who gazes at the stars. This method turns the galaxy itself into a communal sketchbook, suggesting that the universe's beauty might be punctuated with deliberate signatures. And if a civilization can sculpt the substance of space, it may also learn to orchestrate the flow of time. A message could be waiting for its intended recipient, not just across space, but across time itself. This 15th method, temporal delayed echoes, redefines the very nature of a signal. An advanced civilization, operating with a physics that allows for closed time-like curves or subtle manipulations of causality, might not simply broadcast to the present. They could carefully engineer events whose significance only unfolds at a predetermined moment in the future. Think of a stellar explosion, a supernova, whose light they have calculated will reach a specific world exactly when that world's inhabitants develop radio telescopes and the scientific understanding to decode the subtle patterns hidden within the blast's radiation profile. The supernova itself is not the message, its impeccable timing is. For us, it would appear as a cosmic coincidence of unbelievable precision, a cataclysm that just happens to arrive at the perfect cultural and technological moment for us to recognize it as something more than nature. Alternatively, such a civilization might practice interstellar archaeology, leaving behind inert artifacts on young, lifeless worlds. These objects will be designed to remain utterly dormant, perhaps for billions of years, until triggered by a specific stimulus. This trigger could be a natural increase in background radiation from a developing industrial civilization, or the first artificial radio waves leaking from a planet. Suddenly, the artifact activates, beginning its true purpose as a communicator or a data repository. It was always there, a message in a bottle buried in the sands of deep time, waiting for the right hands to dig it up. Finding such evidence would mean looking for events that feel a little too convenient, a little too perfectly scripted. Is the remnant of a nearby supernova suspiciously rich in certain isotopes arranged in a pattern that mirrors a fundamental mathematical constant? Did a peculiar object on Mars or the Moon only begin emitting a faint, structured signal after humanity launched its first satellite? This form of communication blurs the line between science and prophecy, suggesting that some of the phenomena we record might be deliberate dispatches from the past, tailored specifically for our era. It turns the entire timeline of the universe into a potential narrative, carefully plotted by intelligences we may never meet, but whose words are written into the very history we are uncovering. This manipulation of time itself relies on a physics we can only dream of, yet it uses the most common particles in the universe as its ink. The faint whisper of interstellar hydrogen might be carrying more than just the story of the cosmos. It could be a hidden conversation happening on a channel so fundamental that any advanced species would know to listen. This is the hydrogen line, a specific radio wavelength of 21 centimeters emitted by the most common substance in the universe. Because neutral hydrogen is everywhere, this frequency is seen as a universal meeting point, a cosmic watering hole where different civilizations might naturally gather to communicate. An advanced species would not need to invent a new channel. They would simply use the one the universe has already provided. They could broadcast by subtly manipulating this omnipresent signal, encoding complex data within its seemingly random emissions. They might superimpose a message onto the background hum of hydrogen from a distant galaxy, creating a spectral anomaly that stands out against the natural noise. Our own SETI programs have long listened near this frequency, but they often search for simple, narrow-band signals, a deliberate and obvious hello. A truly sophisticated message would be far more nuanced, using broad-band modulation or complex spread spectrum techniques that artfully blend into the natural static, making them incredibly difficult to distinguish from the universe's own background chatter. To find such a signal, we would need to do more than just listen for a single tone. We would have to analyze entire all-sky maps of hydrogen line emissions, searching for regions of space where the spectral features seem unnatural. Are there repetitive patterns woven into the hydrogen's faint glow? Does a specific cloud of gas exhibit information-rich structures, like a complex mathematical sequence encoded in the variations of its radio whisper? This method leverages the most basic ingredient of the cosmos as its carrier wave, turning the raw material of stars into a potential network for dialogue. It suggests that the answer to our cosmic loneliness might not be a loud shout, but a quiet, deliberate modulation of the universe's most common song. And if a message can be woven into the very gas between the stars, it could also be carved into the bedrock of distant worlds. The surface of a dead world could be its final monument. If a civilization wanted to leave a message that would outlast its own sun, it might turn to planetary geology itself. Instead of fleeting signals, they could carve their story directly into the crust of an airless moon or a barren planet, creating astroglyphs on a continental scale. Imagine a perfect circle hundreds of miles across, etched into the Martian desert, or a colossal representation of a DNA helix carved into the icy plains of Europa. They could arrange a chain of craters not by random impact but by directed energy to spell out the first 100 digits of pi. These would not be subtle signs. They would be blatant, permanent, and undeniable declarations of intelligence, visible to any species that develops the optics to see them. The engineering required is staggering, involving planetary-scale manipulation that could use focused solar energy or advanced nanotechnology to sculpt the landscape over centuries. Yet the result is a message in the most durable bottle imaginable, one that could endure for billions of years, waiting patiently for a visitor or a distant observer to finally look in the right place. We are, in fact, already in a position to find such artifacts. Our lunar orbiters have mapped the moon in exquisite detail. Our rovers and satellites have scanned vast stretches of Mars. So far, we have seen only natural formations, the beautiful chaos of geology. But what if a future survey, perhaps using artificial intelligence to scan for unnatural geometric perfection, suddenly flags a region on the far side of the moon? What if it finds a valley on Mars where the rock layers are arranged in a perfect Fibonacci spiral? The discovery would be instantaneous and world-changing. This method transforms entire worlds into libraries, their surfaces holding a silent, patient language meant for the ages. It suggests that the most profound message we might receive from the stars is not a signal we hear, but one we see, written in stone and waiting in plain sight. And just as a civilization might sculpt a planet's surface, it could also learn to conduct the chaotic symphony of its atmosphere. A planet's invisible shield could be broadcasting its own story. The Van Allen belts surrounding Earth are vast, donut-shaped regions of high-energy particles, trapped and held in place by our planet's magnetic field. This natural phenomenon is not unique to our world. Many planets likely possess similar magnetospheric envelopes. For a civilization that has mastered its own environment, these belts are more than just a protective barrier. They are a ready-made planetary antenna. Imagine an advanced society deploying orbital energy projectors, devices designed to inject precise bursts of particles or electromagnetic energy directly into these zones. Each injection would cause the entire radiation belt to ring like a bell, emitting a cascade of radio waves as the disturbed particles interact. By controlling the timing, location, and intensity of these injections, they could encode a complex data stream into the planet's own fluctuating emissions. From a distance, this world would not appear as a steady point of light, but as a star that pulses with an intricate, intelligent rhythm across specific radio frequencies. It is the ultimate in stealthy signaling, a broadcast that requires no colossal engineering projects visible from space, only a deep understanding and subtle manipulation of a world's existing systems. Detecting such a signal is a task of immense patience. Astronomers would need to monitor candidate exoplanets for years, building up a long-term profile of their magnetospheric activity. They would be searching for a pattern hidden within the natural chaos of stellar flares and solar winds, a sequence of radio pulses that is too orderly, too information-dense to be the product of random space weather. Finding it would mean that a planet's magnetic heartbeat has been deliberately tuned to carry a message, turning a fundamental feature of a habitable world into its most powerful beacon. This deep integration with a planet's natural forces hints at a civilization living in harmony with its world, using the very forces that protect it to reach out to the stars. And if a message can be written into the dance of trapped particles, what could be encoded in the fundamental code of life itself? The very code of life could be a message in a bottle. Panspermia suggests life might hitchhike across the cosmos on asteroids and comets, but an advanced civilization could turn this natural process into a deliberate mailing system. They would not just be spreading life, they would be seeding information. Imagine engineering a meteorite to contain strands of synthetic DNA, its sequences meticulously arranged not to form a living organism, but to act as a biological hard drive. Within the double helix, vast libraries of knowledge could be stored, from mathematical theorems and star maps to the entire history of a species. The meteorite is then nudged onto a trajectory that sends it drifting into a young star system, a silent courier on a voyage that could last for millions of years. Its intended recipients are not any specific race, but any civilization that eventually rises to the challenge of genetics. The moment that world develops the technology to sequence DNA, the message reveals itself. We are already experimenting with this very concept, encoding books and images into synthetic DNA in labs on Earth. An alien version would simply be far more advanced, perhaps built with a robust, cosmic ray-resistant genetic alphabet designed to survive the harshness of interstellar space. The discovery would be staggering. A scientist analyzing a meteorite sample would find a DNA sequence that is clearly, undeniably artificial. It might spell out the first 10,000 digits of pi in its base pairs, or it could contain a simple bitmap image of a star chart pinpointing its system of origin. This method is the ultimate exercise in patience, a communication strategy that operates on geological timescales. It suggests that the building blocks of life we so eagerly search for in space might occasionally be more than just ingredients. They could be envelopes, carefully addressed and sent across the galaxy, waiting for us to open them. This biological return address leads us back to the realm of immense, raw power. The universe's own flaws could be the most durable wires for a galactic telephone network. Cosmic strings are hypothetical cracks in the fabric of reality, relics from the universe's violent birth. They are not made of matter, but are pure distortions of space-time, unimaginably dense threads thinner than an atom yet stretching across the entire cosmos. For a civilization that has mapped these primordial flaws, they would present a unique opportunity. They could learn to pluck these cosmic strings, much like a violinist draws a bow across a string. This would not create sound, but would generate powerful, resonant vibrations in the fabric of spacetime itself, producing gravitational waves or other forms of radiation. The information would be in the music, encoded within the precise frequency, amplitude, and harmonic overtones of these vibrations. A simple message might be a single, pure tone, while a complex data stream could be a symphony of interwoven harmonics. The true advantage of this method is its incredible stability and longevity. A cosmic string could persist for billions of years, offering a communication channel that is virtually eternal and immune to the decay that plagues stars and planets. Detecting such a signal would be the ultimate challenge for our gravitational wave observatories. They would be searching for a continuous, perfectly monochromatic wave, a single, unwavering note in the cosmic background. This is unlike the chirps and bursts we see from merging black holes, which are transient and chaotic. Finding a gravitational wave signal that is too pure, too constant, and too perfect to have a natural source would be a strong hint that someone or something is playing the universe's fundamental strings. This represents a form of engineering that manipulates the foundational cracks of creation, turning the universe's own imperfections into a permanent intergalactic network. Such a concept forces us to look beyond the objects within the cosmos to the very structure that contains them. And if a civilization can manipulate the threads of spacetime, it might also learn to surf the wave of its expansion. The stage of the universe is not a fixed set, but a dynamic fabric that can be folded and pleated. Metric engineering takes this idea to its ultimate conclusion, proposing that a masterful civilization could learn to sculpt spacetime itself into a communications medium. This is not about sending waves through the cosmos, but about momentarily changing the shape of the cosmos to carry a signal. Imagine generating a microscopic, stable wormhole, a tunnel through the folded fabric of reality, and then deliberately causing it to collapse in a specific, rhythmic sequence. Each collapse would send a unique tremor through the gravitational field, a pulse that could represent a 1 or a 0 in a complex data stream. Alternatively, they might create tightly packed gravitational wave packets, not the chaotic ripples from colliding black holes, but clean, engineered distortions that travel through space carrying information in their precise geometry. The message is the distortion itself. This form of communication is built entirely on the principles of general relativity, treating gravity not as a mere force, but as the curvature of the stage upon which everything else performs. The signals would travel at the speed of light, or, in the case of a wormhole conduit, potentially bypass distance altogether through a shortcut in the continuum. For us, detecting this requires a leap in our own technology. Our current gravitational wave observatories are like ears that have just learned to hear the loudest crashes in the universe. To catch these subtle, engineered whispers, we would need a network of detectors with unimaginable sensitivity, capable of resolving the fine-scale structure of a gravitational signal and distinguishing an artificial, information-rich pulse from the background rumble of the cosmos. The theoretical groundwork for such feats already exists in the equations of physics, exploring the stability of wormholes and the mechanics of warp drives. Finding evidence of metric engineering would mean discovering that the most advanced language in the galaxy is not written in light or matter, but in the very shape of reality. It suggests that the ultimate network is the spacetime continuum, manipulated by its most intelligent inhabitants. After learning to bend the cosmos to their will, a civilization might turn to the simplest and most abundant energy source for its broadcasts. Even the light from a distant star holds a secret signature we rarely think to check. Most of our telescopes are designed to measure a star's brightness or color, but they often ignore a crucial property, its polarization. This is the specific orientation of the light waves as they travel through space. When starlight passes through clouds of interstellar dust or navigates cosmic magnetic fields, it becomes naturally polarized in a random, messy way. An advanced civilization, however, could turn this natural effect into a deliberate signal. They might construct colossal, orbiting filters like vast, slatted blinds placed between their star and the rest of the galaxy. As the star's light passes through these megastructures, its waves would be forced into a specific, artificial orientation, Alternatively, they could generate immense, controlled magnetic fields around their star, fields that would systematically polarize its light in a complex, coded rhythm. The resulting message would not be a flash or a pulse, but a steady, persistent signal etched directly into the star's very glow. This information would then stream across the galaxy, hidden in plain sight within the light we see every night. Detecting this whisper requires a special kind of eye. Our telescopes would need advanced polarimeters, instruments specifically designed to measure the polarization of light. Astronomers would then survey the sky not for brightness but for pattern. They would be searching for stars whose polarized light tells a strange story. Does the polarization from a particular sun shift in a precise, repeating sequence that mirrors a mathematical constant? Does a nearby nebula exhibit a polarization map with sharp, geometric shapes that defy the chaotic swirls of nature? Finding such an anomaly would be like discovering a hidden barcode on a star. This method is profoundly stealthy because it leverages a channel we largely ignore, embedding a conversation within the most fundamental signal the universe sends us, light itself. It suggests the sky is not just a collection of points of light, but a tapestry woven with potential messages, if only we learn to read the weave. And if a civilization can manipulate the light from a single star, what could it achieve by coordinating the subtle signals from billions of them at once? A galaxy could be thinking, not as a single entity, but as a distributed mind composed of countless tiny, intelligent parts. This is the 23rd method, the swarm intelligence of probes. Envision not one large ship, but a cloud of microscopic von Neumann replicators, self-replicating machines that have spread from star to star, multiplying until their numbers are as vast as the stars themselves. Each probe is a simple node, but together they form a decentralized, living network, a true intergalactic internet. They communicate with each other using faint, short-range laser or radio links, passing data from one node to the next in a cosmic game of telephone that spans light years. A message from a civilization in the Andromeda galaxy would not be beamed directly at us. Instead, it would hop patiently from probe to probe across the void, a relay race run by machines that never tire. This mesh network offers incredible resilience. Destroying a few probes, or even a few million, would be like removing a handful of sand from a beach. The network would simply route the information around the damage, healing itself automatically. The collective behavior of this swarm is where its true intelligence lies. The probes could coordinate to perform tasks no single machine could manage. They might adjust their positions with perfect synchronicity, forming a vast, reflective surface that focuses a star's light into a pulsating signal aimed at a developing world. Or they could arrange themselves into a colossal antenna, amplifying a faint whisper into a detectable broadcast. How would we ever detect such a subtle presence? We might observe a strange, shimmering haze around a distant star, a cloud that moves with a coordination that defies the random drift of cosmic dust. Our telescopes might catch a series of impossibly brief, repeating signals that appear to leapfrog across different points in space, tracing the path of data flowing through an invisible network. It would be like watching a flock of starlings move in perfect, intelligent unison, a display of collective behavior that reveals a mind far greater than the sum of its parts. This vision represents a civilization that has fully merged with its own technology, spreading its consciousness and its means of conversation across the entire galaxy, not as an empire but as an ecosystem. This distributed form of intelligence relies on manipulating the physical world, but a truly advanced civilization might communicate using the very laws that govern it. The very atoms that make up our world could be whispering secrets. deep within the nucleus of every atom, the weak nuclear force governs one of the universe's most fundamental processes, radioactive decay. This is the slow, inexorable ticking of a cosmic clock, as unstable elements transform into more stable ones, releasing energy and particles over vast stretches of time. Now consider a civilization that has learned not just to observe this clock, but to control its hands. They could take a block of a radioactive isotope and, through a technology we cannot yet conceive of, artificially induce its decay not randomly, but in a precise, patterned sequence. Each accelerated decay event would release a predictable burst of particles, such as neutrinos or gamma rays. By modulating the timing of these bursts, they could encode a complex data stream, turning a piece of matter into a microscopic radio transmitter. The information would be carried on the particles themselves, a binary code written in the rhythm of atomic disintegration. The advantage of this method is its profound stealth and penetration. The weak force is notoriously difficult to shield against, and the neutrinos it often produces can pass through entire planets without being stopped. This makes it ideal for secure, point-to-point communication, a private line that cuts straight through stars and nebulas to reach its intended recipient. For us to ever eavesdrop on such a conversation, we would need a new generation of particle detectors. These would not just count decay events, but analyze their timing with nanosecond precision, searching for sequences that defy the inherent randomness of nature. We would be looking for a block of radioactive material somewhere in space that seems to be ticking with a perfect, intelligent rhythm, a rhythm that spells out a message in the decay of its own atoms. This concept suggests a level of mastery where a civilization communicates by orchestrating the fundamental processes that dictate the stability of matter itself. It turns the quantum realm into a secure channel, a whisper so subtle it is woven into the fabric of reality. From this intimate control over atomic nuclei, we expand our view to a method that operates on a truly planetary scale. The clockwork of a solar system might be ticking out a deliberate code. Orbital resonance is a natural gravitational ballet, where two orbiting bodies exert a regular, periodic influence on each other, often settling into a rhythm where their orbital periods form a simple ratio, like 2:1 or 3:2. But an intelligence that has mastered celestial mechanics could choreograph this dance on a grand scale. They could artificially engineer the orbits of countless objects within a system, from a swarm of asteroids to a collection of moons, forcing them into a complex, system-wide resonance pattern. This intricate arrangement would not be for power generation, but for communication. Imagine a civilization nudging hundreds of small bodies into precise paths around their star. From our distant vantage point, we would see that star dim in an incredibly complex but perfectly repeating sequence as each object transits in a preordained order. The timing of these dimmings, the duration of each occultation, could spell out a message in a form of binary or even a more complex mathematical language. The entire solar system becomes a vast kinetic sculpture and a clock, its message broadcast through the gravitational interplay of its own components. Our planet-hunting missions like Kepler and TESS have already catalogued thousands of star systems, some with bizarre and unexplained orbital architectures. An artificially engineered one would stand out starkly against this cosmic background. It would exhibit a precise, mathematical harmony that defies all natural formation models, a symphony of motion too perfect to have arisen by chance. This method is a testament to patience and long-term thinking. The initial setup would be a monumental undertaking, but once complete, the system would run on its own for millions of years, a self-sustaining beacon declaring its creator's genius to anyone who learns to read the language of orbits. It is a message written not in light or sound, but in the silent, perpetual motion of worlds. This grand manipulation of celestial dynamics hints at a mastery that extends beyond arranging planets to actually warping the dimensions that contain them. The magnetic fury of a star could be sculpted into a language. Large-scale magnetic field reconnection is one of the most violent processes in nature, a cosmic short circuit where the magnetic field lines around a star or a planet snap and violently reconnect, releasing a staggering torrent of energy as solar flares and intense radio bursts. An advanced civilization would not merely seek shelter from this stellar rage, they would seize the reins. Imagine them building colossal orbital structures, perhaps networks of superconducting loops or powerful energy projectors, designed to artificially stress and manipulate their star's magnetic field. They could induce these reconnection events on command, creating a controlled series of energetic explosions. Each colossal flare or piercing radio burst becomes a single, powerful symbol in a cosmic semaphore system. The message is not in the light or the sound, but in the precise, intelligent timing of these stellar tantrums. For us to detect such a signal, we would need to observe a star that behaves unlike any in our models. We would look for a sequence of solar flares that pulses with a perfect mathematical rhythm, a pattern that repeats with a precision no natural solar cycle could ever achieve. Or we might detect radio bursts from a distant gas giant, its magnetospheric storms crackling with a complex modulation that carries the unmistakable signature of information. This method represents the ultimate domestication of a star's raw power, turning its most chaotic and destructive weather into a reliable, high-energy broadcast system. It suggests that some of the stellar activity we chart from distant suns might not be random turbulence at all, but a deliberate form of speech written in magnetic fire. Such mastery over stellar forces relies on immense power, but some conversations might unfold with a patience that spans eons, using a far more common cosmic vibration. The entire galaxy could be humming with a single, structured thought. Our Milky Way is not a static collection of stars. It is a dynamic system with its own fundamental rhythms, including a vast, thin layer of electric current flowing through its disk. This is the galactic current sheet, a fundamental feature of our cosmic home's magnetic architecture. A civilization that has mastered astronomy on this immense scale would see this not as a curiosity, but as the ultimate communication grid. They could learn to modulate this current, sending deliberate signals that resonate across the entire galactic plane. The method would be one of subtle, immense influence. By injecting precise bursts of energy or carefully controlled streams of charged particles into the sheet at specific locations, they could create controlled ripples and oscillations within the current itself. Information would be encoded in the precise frequency, amplitude, and pattern of these vast, slow-moving waves. These signals would be incredibly low frequency, meaning they would travel slowly, perhaps taking centuries to cross the galaxy, but their reach would be phenomenal. A single, modulated pulse could eventually wash over billions of star systems, a single announcement broadcast to the entire spiral arm. Detecting such a signal is one of the greatest observational challenges we can conceive. It would require monitoring the galaxy's large-scale magnetic and electric fields with a sensitivity and scope we do not yet possess, searching for coherent, non-random variations hidden within the natural galactic weather. We would be looking for a pattern in the galaxy's own heartbeat, an artificial rhythm in the fundamental current that binds our cosmic neighborhood together. This method represents a technology of almost unimaginable scope, a civilization that does not just live within a galaxy, but one that has learned to speak through its very structure. It turns the Milky Way into both the medium and the message, a network where communication is woven into the fundamental currents of our home. From this grandest of scales, we are pulled back into the bizarre and counterintuitive world of the quantum. A stable knot of energy could glide through the cosmos, carrying a message for eternity. This is the principle of topological soliton waves, a concept from advanced physics where a wave packet or a defect in a field does not dissipate. Unlike an ordinary ripple in a pond that spreads out and fades, a soliton is self-reinforcing. It holds its shape and energy over immense distances, a solitary traveler in the void. An advanced civilization might learn to tie knots in the universe's fundamental quantum fields, creating these stable solitons to act as perfect information couriers. Think of it as a sailor tying a complex knot to record a number, then casting that knot into the ocean where it remains perfectly intact until someone else finds it and understands the code. The data would not be in the soliton's speed or brightness, but in its topology, the intricate way it is twisted, linked, or coiled. A simple loop could represent a 0, a figure 8 not a 1, and a complex braid of multiple solitons could encode an entire library of information. The profound advantage is stability. These topological messengers would be nearly indestructible, traveling for billions of years without their signal degrading, passing through interstellar gas and radiation as if they were not even there. For us to ever detect such a signal, we would need a new kind of physics instrument, one capable of mapping the subtle geometry of fundamental fields across space. We would be searching for structures that are topologically non-trivial, mathematical jargon for shapes that cannot be smoothed out into simplicity, like a donut cannot be transformed into a sphere without cutting it. Finding a family of these perfect, stable knots moving through the galaxy in a coordinated, non-random pattern would be a clear sign of engineering. This method, while highly theoretical, suggests the universe might be filled with these enduring data packets, a slow and permanent network woven into the fabric of reality itself. From these near-eternal messengers, we shift to a signal that is the exact opposite, one that lives and dies in an instant. A brilliant blue flash in the cosmic dark could be a deliberate word. This is Cherenkov radiation, the eerie glow that appears when a particle races through a medium like water or gas faster than light can travel in that same substance. It is the optical equivalent of a sonic boom, a shock wave of pure energy. An advanced civilization would see this not as a curiosity of physics, but as a cosmic paintbrush. They could build immense particle accelerators in deep space, aiming tightly controlled beams of high-energy particles at vast, receptive targets. Imagine them firing a proton beam into a nearby nebula, a colossal cloud of gas and dust. As the particles slam into the nebula, they would each generate a tiny, instantaneous flash of that characteristic blue light. The civilization would not be sending random particles, they would be firing them in a precise, coded sequence. The resulting pattern of flashes across the face of the nebula would be their message, a temporary image or a line of text written in light upon a cosmic screen. This turns a beautiful natural formation into a temporary billboard, visible to anyone watching from the right angle. We already possess the basic technology to detect such a phenomenon, at least on a small scale. Our own underwater neutrino observatories, like the ice cube detector at the South Pole, rely on spotting the faint Cherenkov glow created when neutrinos interact with the deep, clear ice. Expanding this concept to a galactic scale, astronomers would search the depths of space for the unexplained. They would look at known nebulae and gas clouds, monitoring them for flashes that defy explanation. A series of coordinated blue pulses appearing in a perfect geometric shape, or a sequence that repeats a complex mathematical ratio, would be a stunning anomaly. It would be a signal that uses the universe's own physics as its ink and its most beautiful structures as its parchment. This method is a testament to creative engineering, turning a fundamental physical effect into a means of expression. From flashes in the dark, we turn to a method that uses the most perfect mirrors imaginable. The ultimate network might exist in a state of matter colder than the void of space itself. A Bose-Einstein condensate forms when a cloud of atoms is cooled to a temperature just a whisper above absolute zero, the point where all motion ceases. In this frigid realm, individual atoms lose their identity, merging into a single, coherent quantum wave, a superatom that behaves as one entity. An advanced civilization could cultivate vast, stable clouds of this condensate in the deep freeze of interstellar space, using them as the building blocks for a network of unparalleled sensitivity. Each condensate would act as a perfect quantum memory bank, capable of storing immense amounts of information within its delicate quantum state. The real magic happens when they entangle these separate condensates across light years, linking them into a web where a change in one instantly ripples through all the others. This network would process and transmit data on fundamental quantum principles, offering not just incredible speed but also perfect security, as any attempt to eavesdrop on the quantum state would disturb it and reveal the intrusion. Finding evidence of such a system pushes our own scientific capabilities to their absolute limit. We would need to detect and decipher macroscopic quantum coherence on a cosmic scale, searching the darkness for the subtle signature of these super-cold clouds. Our observatories might one day register unexplained regions of space that are artificially and profoundly cold, or detect coherent quantum phenomena that have no natural source, like a perfectly synchronized wave function stretching between stars. This 30th method represents the absolute peak of quantum communication, a civilization that has tamed the chaos of matter at its most fundamental level to weave a tapestry of connection as delicate as it is powerful. It is a network built from the universe's deepest chill, having journeyed through 30 distinct possibilities, from gravitational waves to galactic currents and quantum whispers. A profound question remains. What does it mean for us if even one of these channels is active? The sheer diversity of these methods suggests that if other minds are out there, their conversation is not a simple shout in the dark, but a complex, layered symphony. We may be surrounded by a cosmic dialogue, a constant flow of data, art, and knowledge, all happening just beyond the narrow slice of reality we have learned to perceive. Our search until now has often been like listening for a friend's voice in a single room of a vast, bustling city. The true challenge is to expand our senses, to build new ears and new eyes that can tune into the universe's full spectrum of communication. This is not just a scientific endeavor, it is a fundamental expansion of what it means to be part of a connected cosmos. The greatest discovery in human history may not be a single message, but the sudden, humbling realization that we have finally learned how to listen. This overwhelming variety of communication channels shatters the silence of space into a million possible whispers. If even one of these methods is active, it means the cosmos is not a quiet, lonely void but a vibrant arena humming with dialogue we have not yet learned to hear. The famous question, "Where is everybody?" suddenly feels outdated. It assumes that other civilizations would use our technology, that they would shout across the void in a language of simple radio waves we can easily understand. The real answer to the Fermi paradox might be painfully simple. We have not been listening on the right channels. Our search for extraterrestrial intelligence can no longer be a narrow hunt for a deliberate hello. It must become a broad, interdisciplinary mission, a grand scientific synthesis. We need astrophysicists scanning gravitational wave data for unnatural rhythms, quantum engineers designing sensors to detect macroscopic entanglement, and data scientists writing algorithms to sift through the cosmic microwave background for hidden geometry. Biologists must join the hunt, analyzing exoplanet atmospheres for the chemical fingerprints of industry and examining meteoritic samples for engineered genetic code. This is no longer just astronomy, it is a new science of cosmic society. Discovering a single confirmed signal would be the most transformative event in human history, an instant that redefines our place in the cosmos. Philosophically, it would answer the ancient question of whether we are alone, humbling our species while simultaneously elevating our understanding of life's potential. Socially, it could unite humanity under a common cosmic identity, a shared purpose that transcends earthly conflicts. Technologically, it would be the ultimate catalyst, offering us a glimpse into physics and engineering principles beyond our wildest dreams, potentially solving our energy crises, curing diseases, and opening the stars to us. The quest to tap into the intergalactic internet is about more than just making contact. It is a fundamental journey to comprehend the universe's deepest workings and our role within its grand, interconnected narrative. We have traveled from the ghostly whisper of neutrinos to the engineered collapse of wormholes, from the quantum foam to the galactic current sheet. We have explored 30 ways the cosmos might be talking, and in doing so, we have not just looked for aliens. We have begun to learn how to see the universe with new eyes, and in the process, we have started to understand what it truly means to listen. Our journey through 30 ways the cosmos might be talking reveals a universe alive with potential. Each method, from quantum whispers to sculpted starlight, suggests we are not in a silent void but surrounded by a symphony of signals we are only beginning to conceive. The idea of an intergalactic internet is more than a theory. It is a call to expand our perception and our technology. It urges us to build new kinds of ears to hear the gravitational ripples and new eyes to read the quantum static. The greatest discoveries in human history have always come from this willingness to question what we think we know and to venture into the uncharted. If this exploration has ignited a sense of wonder in you, then the real adventure is just beginning. We want to hear which of these communication channels you believe is the most likely. Share your favorite method in the comments and let us know what cosmic mystery we should explore next on this channel. The universe is vast, and its greatest stories are still waiting for us to tune in.